Hello everyone, my name is Abhi Bhardwaj. I'm back with lecture series on science. Today's topic is going to be climate change, and I'm going to talk about one particular greenhouse gas. So we have multiple there. We know that there's carbon dioxide, there's methane, there's nitrous oxide, there's water vapor, there's CFCs, so many of them. But my focus is going to be on carbon dioxide. So let's get started. We're going to see first the global data about all the gases. So when you look at the global data here, about 65% comes from burning of fossil fuel, and this is carbon dioxide. So CO2 burning of fossil fuel causes 65%. And then 11% comes from forestry. So 11% CO2. So I'm talking about CO2 here. So 65, and that's a global data. So burning of fossil fuel, which means transportation, industry, everything which uses fossil fuel, causes 65%, and 11% from forestry. Then we have methane gas. Methane is CH4, and this is about 11%. Okay, and then we have nitrous oxide, which is about 6%, and rest sits here. So major contribution is from burning of fossil fuel, and then rest is forestry for CO2, and that is going to be our discussion today about CO2. But let's see US data now. So when you look at the US data, for instance, the major contributor here, 80%, comes from burning of fossil fuels. And then we have methane, which is same as 11%, so CH4. And then we have nitrous oxide, about 6%. And then we have rest like CFCs and others, I'll say here, which makes the rest. But so major here in US is 80% is burning of fossil fuel. Now, where does this carbon dioxide comes from? Let's check that out. So when we look at carbon dioxide, for instance, there are different sources of carbon dioxide, which is leading to rise in level of CO2 level, CO2 in atmosphere. And what are those? The major one is electricity production. So electricity production causes about, I think, 37%. And then, so that's one which we're going to discuss. Then we have industry. Then we have transportation, actually, which is about 31%. So 31% comes from all the transportation, cars, trucks, trains, whatever uses fossil fuel for running any kind of transportation, causes 31%. Then we have industry, and industry basically causes about 15%. So that's also a significant contributor. Then we have residential, and commercial use also create about 10%. So I will say residential and commercial use, right? 10%, and then remaining rest is at around 6%. So let me increase this here, and then remaining is about 6%. Others, I'll put that. But when you look at electricity production, it's the major contributor here, 37%, right? So that's the major, and then the transportation comes next. But when we see, for instance, when we see that, we are introducing so much of CO2 into the atmosphere so quickly, that is the cause of concern. So when we look at carbon dioxide, for example, when we look at the levels in 1890, there were only 290 parts per million. And if you look at 2015, then they are about 400 parts per million. So this is a steep rise from 1890 to 400. And when did all this started? This started with the Industrial Revolution, mostly after the Industrial Revolution. right? It started and then it keep on going till today, but this was the period basically which led to the steepest rise in the history of the CO2 level. So when you look at the history, for instance, 400,000 years back, it was only 160 parts per million, whereas in 1890 it was only 290 parts per billion, whereas in 2016 it's 400 parts per million now, which is a steep rise. So we have never ever seen such a rise in the history, not only of the mankind. I mean, if you go back 400,000 years, it was 160 parts per million, much lesser than what we have today. And what led to this is the Industrial Revolution mostly, right? So that is what the major contributor is. And what we need to know what is happening now. So say this 400 parts per million, what is it doing? It has already increased the global temperature by 1 degree Celsius, already happened. And now one major problem comes when the temperature of the earth starts rising, and I'll explain it to you why. So when you look at the northern part of the earth, for example, and the south part, this is Antarctica and this is North Pole, I would say. When you look at here, it's all covered with snow and ice, all covered with snow and ice. And what else is there is decaying matter, organic matter. And what does that do? It also has methane gas here entrapped, methane hydrate. In the form of methane hydrate, it's entrapped in the snow and ice here. And same thing in Antarctica. And also we know that 70% is water, oceans. There also we have decaying organic matter at the bottom of the oceans. And the same thing, methane hydrate. When the temperature starts rising, which is doing right now with all these greenhouse gases, what happens is that the snow starts melting from here, and which is already doing, and here, and it's going to raise the sea levels. But that's one problem. The other problem is that the stabilized methane here under low temperature condition, what would happen is as the snow melts and the temperature rises, this will release into the atmosphere. This is extra methane coming into the atmosphere now very quickly both from Antarctica and North Pole. And what would that lead to is further rise in temperature. Why? Because when you look at methane, for example, it's 25 times more potent than CO2. So what would that do once this process starts taking place? Then this is going to start raising the temperature very quickly from 1 degree Celsius to 2, 3, 4, 5, 6. It's going to go very high very quickly. So what we need to do is first address the carbon dioxide pumping. If we do not stop that, then we are going to have big problem here. And that's very important to understand. We are also going to look at country-specific data. So when we look at, for example, countries, when we look at China, for example, is the biggest polluter, #1 right now. Then we have US, then we have Russia, then we have India, and then we have Japan. So these are the countries which are the biggest polluter, but look at the difference between these countries. So when you look at these countries now, if you look at China, for instance, is pumping 8,700 million metric tons yearly. When you look at US, for instance, it is doing 5,500 million metric tons. If you look at Russia, for instance, it's about 1,800 million metric tons. If you look at India, I think it's about 1,700 million metric tons. And when you look at Japan, it's about 1,180 million metric tons. So look at China is #1. And what is happening is that, if we do not take care of this problem, then all these countries basically will keep doing what they're doing. And I think US is taking the initiative, and that's a good thing, that we have we have global leaders, getting involved, and US is taking lead in that. But what we need to do is we have to identify that this has to stop, because if we don't stop it, this is going to really create huge problem for the world in very short time. Once we start releasing, the methane starts releasing, this is going to be uncontrollable, and we don't want to go there. So what we need to do globally together is come up with alternate sources of energy. When we look at, say, electricity production causes 37% of CO2. That's a huge number. What we can do here is switch ourselves to solar power, to hydrothermal, to geothermal, and these are the technologies which needed to be utilized as soon as possible. These are alternate sources of energy which needs to be utilized. For example, first thing is electricity production. Change that to alternate sources of energy. We see that India, for example, is doing great in solar. They have already started investing a lot of money into solar, and which is going to be good in coming years. But every country needs to do and look at that. And developed world basically had to come up with the new technologies and share them with the rest of the world, but also apply on themselves, because we want to make sure that we are not only taking care for ourselves but also globally, because this is a global problem. This needs to be tackled globally, and we need to come up with the solutions together with all other countries, because we want to make sure that we reduce this CO2 level as quickly as possible. Otherwise we will not be able to control it. That's the problem. If you go back into history, the PETM, I always give that example, Paleocene, Eocene thermal maximum, what happened during that time? The CO2 levels spiked quickly to 8 degrees Celsius, led to 50% of all life forms went extinct. 50% of all life forms went extinct in only 8 degrees Celsius, in PETM. So we don't want to repeat that history, but right now what is happening is worse than what happened at the time, because it took 20,000 years at the time. Around 55 million years back in Paleocene, Eocene time, it took 20,000 years to raise 8 degrees Celsius. But here, 1 degree Celsius we have already raised from 1890 to now, 126 years, we are already raised 1 Celsius. If we go couple of more, the CH4 starts coming out from here, which will accelerate this process, and it will lead to 3, 4, 5, 6, 7, and 8 very quickly. And that would be a disaster for this world. So we want to stop that, and we have to collectively stop it. So that was basically the idea of this lecture, to kind of understand how carbon dioxide plays a major role in actually leading to other problems, and what are we doing currently, and what we can do collectively, all around the world, to make sure that we switch as quickly as possible to alternate sources of energy. Otherwise we are already heading towards doomsday. Thank you for watching.